Hello all, welcome back to the IEEE Technologies YouTube channel. Today we're gonna see about license plate recognition. Abstract, I'll explain the abstract first. Uh, a license plate recognition, a LPR system plays a vital role in smart cities by automating vehicle management, traffic control, and the investigation of stolen vehicles. It involves three main stages: license plate localization, character segmentation, and character recognition. Through the LPR is nothing but license plate recognition systems are successfully used in controlled environment like smart parking, challenges arises in congested traffic, ambiguous signage, untitled plates. Here, in a place like India, increasing traffic makes manual rule enforcement difficult and prone to error. Traditional method to Traditional method of traffic management relied on human effort, which was insufficient, prone to data loss. This project aims to design an efficient LPR system that processes vehicle images through thresholding, edge detection, and morphological technique, followed by character recognition using ML algorithms like K nearest neighbors, support vector machine, and decision tree. After recognizing the systems across checks, the license plate detail in the database will be stored. Now I'll explain you the introduction. In this introduction, the vehicle plate recognition is a key technology in intelligent transport system addressing challenges in identifying vehicles from large growing traffic volumes with different license plate formats across countries. LPR system must be adaptable to reusable formats. They also face challenges from environment factors like varying light and weather conditions. So the system uses optimal characteristic technology to automate the manual task of capturing and verifying the license plate. After capturing an image, that is license plate, image of a vehicle, the system locates the license plate and process the image through segmentation and recognize the characteristic using machine learning algorithms like CNN. This automated process significantly enhance accuracy compared to older template machine learning technique. The VNPI systems have application in various areas, including law enforcement, parking management, and road safety. They help detect rule violation, manage vehicle access in parking lots, and identify stolen or speeding vehicles, making traffic management more efficient and less dependent on human intervention. The existing system in the existing system, the segmentation and recognition of license plate are crucial challenges in license plate recognition systems due to various factors. One issue is inconsistent in license plate formats, which differs cities between city, state, and vehicle. Another major challenges is the low resolution of license plate in video frames captured by typical surveillance system. This issue make it difficult to accurate segment the number plate area and recognition characters, particularly when dealing with varying resolution. The proposed system, what we have done is, I'll explain you, the effectiveness of license plate segmentation and the character recognition largely depends on quality of the image. Poor image quality can hinder the segmentation process, but this issue can mitigate by applying a proper sequence of morphological operation to remove unwanted religion and enhance the target area. Using the high resolution camera further improve system performance and robustness, enhancing both speed and accuracy. In this, what we have done is the process of license plate recognition involves four keys, that is image acquisition, that is capturing the image vehicle, uh, license plate extraction, and the license plate segmentation and character recognition. This process automates the vehicle verification and enhances security and reducing human error. Yeah, this is a block diagram. First, we will capture the image of any vehicle, I mean number vehicle, and the image processing we will do here. And by using the YOLO configuration, we will extract the number plate here, and then character segmentation, and the character segmentation and character recognition. This will follow, and this is a flow chart. I will show you the code once. How to done. Yeah, this is our code. Before that, I'll show you our data set. Yeah, this is our data set. So the pilot images we have, and these are the weights we have used in this. And then this is the main code. I'm opening this phone. Yeah, this is our main code. Here, CV2 used for image processing and then display. These are libraries we imported here. And then threshold, this is for confidence threshold is nothing but these are the parameters for YOLO confidence threshold determines which object should be considered as a filter I mean detection which should be detected, and non-maximum suppression is used to reduce the overlapping bounding boxes. It's used for this. Here we are loading the classes. Based on this classes, what we have example if the dog bite, that's what we classified here. These objects are classified and detected by the YOLO. Here we are doing the model configuration. These are the configuration what we have, and then used this model configuration and model gates. We are getting it here. We are getting it here that our network will be run on this CPU only. Our network will run on this CPU, and then here what we are doing is we are getting our output layers name. That means here it will extract what the detected name we have. The names of the output layer, and this will be used to forward pass of network. These layer actually provide our object detected thing. And then in here we are creating a bounding box on rectangle in green color. That's what we're doing here. This is for bounding box. And the portion of image and the portion of the image inside the bounding box is extracted from the text. That is, it will from the rectangle box, it will extract the text from this and will save it as JPG outside. And the label of the class name and confidence scores displayed above the bounding box will be displayed. Here we are doing post process. Here nothing. What we are doing is iterating through the detection from YOLO network output, and you are filtering the based on here filtering this based on this IG confidence score, and then confidence threshold. We are doing this, and then the remaining box will be handled with the NMS boxes. Here we are giving the image, pre-processed image. No, here we're using the input image. That's what we're using here. And then here, our image will be turned into a four dimension. Here, what happening is the image is converted into raw is nothing but a binary large object. Binary large object. In this, this is a 4D matrix. It will normalize our pixel value dividing by 255. It will always a pixel dividing 255. The resize the image and it will resize the image into YOLO's input like 416 height and width size. 416 height and width. And this is forward pass. And our pass will be here. I'll run this so you have a good idea about this. You can see this. Yeah, this is the image what you have here. And you can see the license plate numbers what they produce and this the stored polling value. I'll use some other image. You can have a look at this. Yeah, you can see this license plate K14. It will be saved as temp also. You can see this. See K14 B K14. This will be saved as temp also. In code, we have written as share output in temp. It will be keep on updating. What we have detected, a number, it will keep on updating in temp. Yeah. Thank you for watching our Aislyn Technologies YouTube channel. If you have any doubt about related to the project, you can leave in the comment section. And don't forget to like, share, and subscribe. Thank you again.